Power of Sea Salt, presented by Science at NASA. On Friday, June 10th, when a Delta II rocket blasted off from California's Vandenberg Air Force Base, rumbling into a morning blue sky atop a column of white smoke, some onlookers felt they could smell a hint of salt among the rocket's exhaust. Was it spray from the nearby Pacific Ocean? Or something to do with the payload itself? That rocket was carrying a sensor named Aquarius, on a mission to map the salt of our planet's seas. Researchers suspect that the salinity of Earth's oceans has far-reaching effects on climate, much as the salt levels within our own bodies influence our own delicate internal balance. This is why the Aquarius mission is so important. Based on decades of historical data gathered by ships and buoys, we know the salinity of Earth's oceans has changed over the last 40 years, says Aquarius principal investigator Gary Lagerlof, a scientist at the Seattle-based independent laboratory Earth and Space Research. Something fundamental must be happening to the water cycle. In some regions, like the subtropical Atlantic, salinity is increasing, which means more fresh water is being lost through evaporation at the sea surface. But no one knows why this is happening, nor can anyone pinpoint why other areas are experiencing more rainfall and lower salinity. To solve the mystery, scientists need a comprehensive look at the ocean's salt content. Within a few months, Aquarius will collect as many sea surface salinity measurements as the entire 125-year history record from ships and buoys. Circling Earth onboard Argentina's SAC-D satellite, Aquarius is one of the most sensitive microwave radiometers ever built, and the first NASA sensor to track ocean salinity from space. It can detect as little as 0.2 parts salt to 1,000 parts water, about the same as a dash of salt in a gallon of water. A human couldn't taste such a low concentration of salt, yet Aquarius manages to detect it while orbiting 408 miles above the Earth, says Lagerlof. Salinity, along with temperature, governs the density of seawater. The saltier the water, the denser it becomes. Density, in turn, drives the currents that move heat around the planet. For example, says Lagerlof, the Gulf Stream carries heat to higher latitudes and moderates the climate. When these currents are diverted by density variations, weather patterns such as rainfall and temperature change. Could salinity be prompting such changes? For answers, researchers look to the sky. Aquarius, they hope, will soon reveal the power of sea salt. For more salty tales of Earth science, please visit science.nasa.gov.